Hey guys, I'm just going to show you a quick example of how to use the compounding interest formula. This one right here at the top to help you with your budget project. We also have a similar formula that we will use, that's called the future value formula. And the difference is that with the compounding interest formula, that's something where we're just going to invest a sum of money one time. So I'm going to say, okay, I have this amount of money and putting it into account. I want to watch it grow with interest. Whereas future value formula is something where you're continuously investing. So if you put in money every month, let's say, we would use future value instead of the compounding interest formula. So compounding interest formula is a little bit more basic, and we're going to start with that one. So here's my scenario. How much money will I have in 10 years if I invest $4,000 into an account? And it is, first we're going to try compounded annually. So up here, I've given you all the variables and what they mean. So P is the principal value. And remember, principal is what you initially put in. So let's copy this down here. So P is the principal. So in our case, P is going to be 4,000, right? R is the rate, so the interest rate, which I did not tell you here. So let's say we're getting an annual interest rate let's say 5%. We'll just make it easy here, okay? And N is the number of times this interest is compounded or added on per year. So in some accounts, the interest only gets added on at the end of the year. In other accounts, you might be adding interest, in this case, annually once a year, but we might be adding it monthly. We could add it weekly, or continuously is the last option that we'll look at in a second. So for us, it's annually. That's our N. So N would be 1 because it's annual. And then T is the time in years, which we know is 10. All right, so let's fill in this formula, and then A will tell us how much is in our account. So we start with P, or A equals P, and P is 4,000. That's what I'm putting in. Just like when we did the exponential equations, that first value is your starting value. And then it's 1 plus, again, just like we did with the exponential equations, when we're talking percentages, we want to increase whatever percentage we have by 100% if we're gaining money. So 1 plus, and my rate is 5%. So that's my R. But remember to put that in decimal form. So not 5, but 0.05 over, it says over N over here. And N in this case is 1 because we were doing it annually, right? Close the parenthesis, and then it's N times T, so again 1, times the time in years, which would be 10. All right. So in this particular equation, we can simplify it a little bit. So we have 4,000 times 1 plus 0.05. Well, that's really just 1.05 if I want to consolidate to the 1 times 10 power, or to the 10th. All right. And I would recommend using that same Calculate 84 calculator that's on your iPad. And we can put this all in at once. So 4,000 times 1.05, use the caret for an exponent, and then to the 10th power gives me 6,515 point, and it's money, so I'm rounding 2 decimal places, so 0.58. So if I left that alone for 10 years, that $4,000, and the interest was compounded annually, then I would end up with $6,515 at the end of those 10 years. So I made $2,500 by not doing anything, by just leaving my money alone. Pretty good. Let's see how that changes if we're compounding monthly. So monthly, well, the only thing that's going to change about this formula is that if it's monthly, n is equal to 12, and we'll keep it at the same percentage rate just for simplicity's sake here. So we still have $4,000 as the principal. 1 plus 0.05 is my rate, divided by n, and this time n has to be 12, all right? And that is raised to the n times t, so 12 times 10 power. Now monthly is the number 12, that means 12 times per year. If you said daily instead, then it would be 365 as your n. If you said bi-monthly, that would be twice per month. So you would have 24 there. If it said weekly, there are 52 weeks in a year. So whatever value it says, how often you're compounding is the number you want to sub in for n, okay? And then again, let's put this all into our calculator. So 4,000 times 1 plus, and I can leave that, I want this as exact as possible, so I can leave that fraction there. So parentheses 0.05 divided by 12. Just make sure you're using lots of parentheses. And then raise that to the 12 times 10, or 120th power, all right? Hit enter. So we get $6,588.04. So because it was compounded, excuse me, once per month, we ended up with more money because that interest was added on, and so added on each month, and so it's going to grow faster because if the interest is added on each month, then you have a little bit more in your account to accrue the interest for the next month. So the more often it's compounded, the more money you're going to make. All right. And let's look at the last one, which is compounded continuously. So A equals PE to the RT as our formula. This is the PERT equation. If you had Mrs. Heath, you've probably seen this. All right, so P is still the principal, rate is still the rate, and T is still the time. Continuously means that we're consistently, it's always being added on, that interest. So they use this, what we call the natural base, which is base E. And E is a number like pi. It's like 2.7 something. If you look at your calculator, you see above ln, that's natural logarithm. You have e to the x. So if I did e to the first power, you can see that's what e is actually equal to. So that's the button that you will use when we calculate this answer. But let's fill in all of our information here. So we're going to have the principal, 4,000 times e, and again, e isn't a variable here, it's actually a constant, so it represents the number. The rate, we'll keep it at 5%, so 0.05, and the time is 10 years, all right? So 4,000 times second ln gives me the e, and that's to the 0.05 times 10 power. Oops, I went too many parentheses there. Oh, sugar, 0.05, not 0.5. That would be a 50%, 50% interest rate, which is pretty awesome, but would never actually happen. Sorry, so 0.05 times 10. There we go, that's a little bit more reasonable. So $6,594.89. So you could see that the amount of money we make increases as the value or the interest is compounded more often. All right.